In this video, I'll show you how to solve the ALEKS problem called Calculating Electrostatic Energy Using Coulomb's Law. This problem is going to describe a couple of objects. It's going to tell you what their charges are and their distance apart from each other and the energy associated with their relative position. And then it wants you to recalculate the potential energy of the objects if they are moved to a different distance apart from each other. The problem kind of suggests that you should use Coulomb's law to solve, but you can actually solve this problem using a shortened version of Coulomb's law that looks like this. It tells you that the energy associated with the final positioning of the objects divided by the energy associated with the initial positioning of the objects is equal to the distance between the objects in the initial situation over the distance between the objects in the final situation. So the U term here, this is referring to the energy of the objects, the 11.79 joules, and then also the energy that we're supposed to calculate here. And the R is referring to the distance apart from the distance between the two particles. The 1 and the 2 are referring to the two relative situations. So I'm going to use the subscript 1 to indicate the initial situation. So I'm going to say that my initial energy in the initial configuration of these particles, the initial energy is 11.79 joules. I'm going to call that my U1. And the initial distance between the objects is 61 meters. We don't need to use the charges on the objects. We would need to use that if we were using the full big, huge Coulomb's law, but we don't need to use it. And then the new potential energy that we're trying to calculate, that's U2. The distance that the objects have been moved to is 305 meters. That's our R2. So plugging in what we know from the problem, U2 is our unknown variable. U1 is 11.79 joules. R1 is 61 meters. R2 is 305 meters. And you might be given distances with all kinds of units on them. It could be centimeters or millimeters or whatever. The units of your distance don't matter. They don't have to be in units of meters when you're using this version of the problem. The units for your distance just need to be the same. Whatever the unit is, it just needs to be the same unit so that those units can cancel out like I just did right there. And we are going to solve for U2. We're going to multiply both sides by 11.79 joules. 11.79 joules. That will allow that to cancel on the left-hand side. And U2 is going to be 61 times 11.79 divided by 305. It gives us 2.358 joules. The problem wants 3 sig fig, so that's 2.36 joules.